Good morning, class. This is our new topic, which is correlation. If we talk about the last chapter we have done, that is measure of central tendency and measure of the dispersion. There we have dealt with the single variable, only one variable, right? And we computed the averages, mean, mode, median, and the standard deviation in terms of the variation, right? But here we are dealing with the two variable in the correlation. Means these two chapters totally depend on the one variable, and this correlation depend on the more than one variable. Now this is what is the one variable. In the last two chapters, when we need to calculate mean, standard deviation, there always one variable mentioned. Like if see the question that we need to calculate the mean of the height, mean of the weights, standard deviation of the height or standard deviation of the maid, salary of the individual, right? So these are some examples, and these are the, again, if I talk about in correlation, we need to uh, take into account more than one variable, right? It means two variable is required to done the correlation. So if I'm talk about that, if I compare weight with the height, right, or want to know the what is the relationship between the height and weight, it means I want to find out the correlation between two, means what relationship they are having, right? So in this case we need to calculate the correlation. Correlation basically tells us the direction of the relationship and strength of the relationship, how strong the statistical relationship between the two variable. So this is my first slide where we need to understand about the strength and the direction of the relationship. So the strength is the, we can get the strength that how the relationship is strong between the two variable. So there is, we have whole parameter under which we can understand how much strong the relationship between the two variables, and the strength, this direction of the relationship. Here we need to understand, are there any positive relationship, means they are moving together, or they are moving opposite, right? If they are moving opposite, it means they have a negative relationship. So that we need to understand first. And this is linearly, right? This is, we need to understand the simple linear. Is it because we are dealing with the simple linear equations, we can say. It means that if the value of x is given, we can easily compute the value of the y on the basis of the x. So the constant change is there. It means there is simple linear relationship between the x and y. So that if we take an example of this, if you have some knowledge as to the strength and the direction of the relationship between two variable x and y, it is possible to make a prediction about the likely value of y on the basis of the x, right? If अगर आपके पास x की वैल्यू पता होगी आपको, and there is certain equation as well about x and y, right? वो शो करते हैं कोई relationship between an x and y, and you have a value of x for the certain levels, so you can easily find out the value of y. So when you graphically show the values, so you can see the graph that how these values are moving, right? So these values can show us the relationship between the two. So how can we measure the correlation? There are three methods. There are more than three methods, but in our syllabus there is three methods we need to understand. First is scatter diagram. Second is Pearson coefficient of correlation, because it is given by Pearson, and we can also call R or Pearson's coefficient of correlation. Third, we have coefficient of correlation by rank differences, because this is given by the Spearman rank. Spearman, that's why it's called the Spearman's rank correlation as well. So first, let's look at the scatter plots, right? As I talked about that we need to understand the relationship between the two, right? For example, height and weight. I took here height and weight. So we are, want to know that is there any relationship between the height and weight, right? So I have 6 cases where the height and weights are mentioned. So this I want to locate on the graph to look at is there any movement, right? If there any pattern they are making, so we can get to know their which direction they are moving, right? But if you see the scatter plot, there is no such direction. They are just, so just a straight line, you can say, right? Which is horizontal straight line. They're moving, so this is very simple method and extremely useful to get the idea of the pattern of the pattern and the direction of these two variables. So here are some of the patterns of the scatter diagram. So look at the first diagram or first picture, that it shows the perfect positive correlation. It is positively sloped, right? Positively sloped and perfect line. It's showing perfect line. So if it is given here in the straight line, and which is a very rare result, that means it's a perfect positive correlation. Same with the negative. If we are getting the negatively sloped straight line, it means there is perfect negative correlation. If there is sum of the spread, it means there is strong positive or negative relationship. If there is a wide spread but still showing some pattern, positively sloped or negatively sloped, it means it's weak positive or negative correlation. But if it's showing straight line, vertical or horizontal, and all the values are just spread over the graph, it means there is no correlation. You can look at the last 3 pictures which is showing the same, that there is no correlation. If we see the last picture, it is also showing us somewhat the straight line, right? So it means by looking at that picture, I can see that there is no correlation. But we can't totally rely on this scatter diagram. We need to compute the value of R as well to have effective knowledge of the correlation. So for that we need to, either we can follow the Pearson's coefficient of correlation or Spearman correlation. So let's look at the Pearson's. The value of R means the correlation. Pearson's coefficient of correlation is the R. So this R is basically ranges from -1 to +1. It shows that if the values are in the minus, if you are getting -1, -0.8, -0.6 or -0.2, it means the relationship between the two variable is negative. If you are getting all the values in the positive side, means it's the positive relationship, like you can see in this picture. So they have classified, like if you get the +1 means you got the value of 1, that is +2, you have a perfect positive relationship. If the value lies between 0.8 to 0.99 means you have a very strong relationship. Same goes with it. If your value is like -4 to -0.6, it means you have a moderate negative relationship, right? So these are the value which shows us how the relationship, the strength of the relationship. It's a perfect, strong, very strong, weak, very weak, or no correlation, right? So this is the formula of the correlation. Okay, so we know the formula here. The COVXY is equal to covariance between the variable x and y. Now where the hell is covariance come into the picture? Yes, it is also show us the relationship between the two variable. If the value means if the relationship between the x and y is positive, or calculation of the covariance between the two variable is showing the positive value, it means it is positive linearly, right? So they have a positive linear relationship between two. If the covariance between x and y is showing the negative value, it means there is negative linear relationship. Okay, and this is the standard deviation of x and standard deviation of the y, which have already know how to calculate it, right? So here's the formula of the covariance. Covariance is the sum of the product of the x and y. And what is x and y? I can take it, this x is here. If I can say, you are simply taking the value or variation from the mean, and for the y also you are taking the value or deviation from the mean of the y and divided by n. So here is the formula. So we have 2 or 3 formula, and I am here explaining one formula. So first of all, calculate the average or mean prices of here I just wrongly mentioned, it's not price, average of the whatever variables are given. So I am here calculating the average of height and average of weight. So sum of the value of height and sum of the value of the weight, I got 375 and 649. If I divided by the 6, that is the number of cases here in this question, I can get the mean value of the x and y, right? Now the second step is find the differences between each value and the mean variable. So the small x and small y is showing the difference between the or the deviation from the mean value, right? So here I can get it, just multiply small x and small y, you get the sum of small x and y and divided by n. So this is your covariance, which is 42.08. It means the covariance is positive, means there is a positive linear relationship between weight and height.